Section 1.3 Graphical Summaries. In this video, we are going to look into graphical ways of representing data. Those include histogram, boxplots, and scatterplots. The first case that we are going to look is stem and leaf. Let's see, for example, this data set. This is the time to wait for a doctor appointment. And the data that we gather, it is something in between 7 minutes to 146 minutes. It's quite broad. But apart from that, yeah, that's a long time. We'd like to see how that data is distributed. How can we easily interpret? So for example, we would like to see how many patients have to wait in between 0 and 10 minutes. How many of them have to wait into 10 to 20, between 30 to 40, and so forth. So the best ways to classify this data is to have the tens are going to represent the stem, and the ones are going to represent the leaf. So for example, if we look, and I ordered the data for simplicity, usually is not ordered, we'll see that in between 0 and 10 minutes we have two data sets, and 2 are 7. So the stem is 0 and the leaf is 7, so we have 2 patients that wait 7 minutes. Now in between 10 to 20 minutes we have these 12, 13, 18, and 18. So the stem is 1 for all of these cases, so 1, and the leaf, we just put the 2, the 3, the 8, and the 18. Now we look into the 20 to 30 minutes. So we have 23, 25, 27, all of those. So we put the stem and then the 1. So we have 3, 5, and then 1, 2, 3, 4, 5, 6 sevens, 1, 2, 3, 4, 5, 6 sevens, 2 8s, and 1 9, 2 8s, and 1 9. So we keep doing the same thing with all the data. So when we get to this point, so we have 14, for example, 141 minutes. So that means 14 times 10 plus 1. So we can organize it in 14 as the stem, and 1 as the leaf, 14 as the stem, and 6 as the leaf. So 1 and 6. So the key to interpret this stem, so the key is that we have the stem will represent tens, the stem multiplier is equal to 10. So when we have x, which is the stem, pipe, and the leaf, a y number, that will represent x multiplied by 10 plus y. I take any in particular, like for example this one. So we have 9 multiplied by 10 plus 6, so that's 96. And let's take, for example, this case. So that will be 12 multiplied by 10 plus 6, so that's 120 plus 6 equal to 126. Okay, so what is interesting that we found? So basically we found two tendencies. A lot of the patients have to wait around 40, about the 40s, but also a lot of the patients have to wait about the 110 to 120 minutes. So that probably is telling us something else about the data. It could be that we can find some of the doctors were like family doctors and they are very busy, and some of them were doctors that are very specialized, so they are not very busy. So the ones that are not very busy could be those ones, and the family doctors could be those ones. So there is information that we can't extract from looking into this kind of plots. So let's continue with another kind of plot. Oh, but before, let's do one example. So in this example, we have this data set that I got randomly, and it's good for us to have the stem as a factor of 10. So the stem and the leaf. So the stem will be, so our range is in between 10s to 40s. So we are going to have the stem is going to be like 1, 2, 3, and 4. So now we start to classify the ones that are in the ones. So the ones that are in the ones, that's it. So we have 0, 0, and 5. The ones that are in the 20s are, let me change color, 22, 25, 28, 23, 29. So we have 2, 5, 8, 3, 9. We don't really have to sort them. It could be nice, but we don't really. What is important is the frequency, how many of them are in the 20s. And in the 30s, we have 1, 3, 1, and 6. We have 1 and 6. And in the 40s, we have 5 and 8. So we can see from this visualization that most of the data is around the 20s. Okay, now let's see another way of reorganizing data, and this is dot plots. In a similar fashion, so this example is related with how long does it take you to eat a breakfast. And so these are the results after looking into a group of people, that's a sample. So some of them it took in between 0 to 10 minutes. So what we do here is that we really don't want real numbers, we want like integers numbers. So these zeros represent in between 0 to 10. These ones will represent in between 10 to 20s, and thus probably will be like 100 minutes, 110 minutes, something like that. So some people are really fast, some people are really slow. So how do we organize this data in this way? Well, in a similar fashion, well, we just don't write the numbers, but we just make dots. And let me do the dots with a different color. So in the 0 to 10, so we have 1, 2, 3, 4, 5, 6 zeros. So 1, 2, 3, 4, 5, 2, 4, 6, 2, 4, 6. Then in the ones we have 2 ones. In twos we have 3 twos. Oh, sorry. We need a 0. We have to move this. So I'm missing the 0. In the twos we have 3 twos. 1, 2, 3 twos. In the threes we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'll should try to make them like equally the same space. We have 2 fours. 1, 2, 3, 4, 5 fives. 1, 2, 3, 4, 5 fives. 2. We don't have 6. We have 8. We have 2 8s. We have 3 9s. We have 1, 2, 3, 4, 5, 6, 7 10s. 1, 2, 3, 4, 5, 6, 7 10s. We have 1, 2, 3, 4 11s. 1, 2, 3, 4. 1, 2, 3, 4 11s, and we have 1 12. So in the same way, we can see that there are some group of people that are in between this range. Some of them are really have fast breakfast, but most of them are around this range. But also there is a group of people that takes longer to have breakfast. So we can reorganize like into, I would say, 3 different groups. The ones that are really fast, the ones that are relatively fast, well, I wouldn't say 40 minutes fast, and the ones that are really slow. I know some of them. Okay, let's continue. So dot plots are basically useful if our information is an integer information. So because we don't, well, we kind of compress the range by saying in between the 10s and the 20 minutes. Okay. Let's see a more broadly used way of graphing information, and this is the histograms or histograms. So in histograms, the main difference is that we are going to have a range of numbers. So we are going to have in between 100 and 150 in this case. Let me increase it. And then this is the frequency on the left hand side. So how many elements we have in between 100 and 150? So 20 something. So always in a histogram, the left hand, the vertical axis is the frequency, and this is the range of elements that we are studying, the data sets. One important thing about histograms is that we make these rectangles that are called bins, and there is no space in between them, because if there is a space in between them, it means that there is a range which doesn't have any frequency at all. So the space is meaningful in a histogram. So as opposed to, this is a bar diagram. A bar diagram, we have categories like, I don't know, this is the cost of something in different countries. So this is USA, India, UK, New Zealand, and Japan. So this is not frequency, this is a bar diagram. In the bar diagram, we can have a space because we want to separate visually the data. In the case of the histogram, space means that there is no frequency in some particular range. Okay, so remember that we have, oh, that's quite thick, that we have our bins. So we have frequency in this side, and in this case we have a range. So this is the range value, and we have a rectangle, and that rectangle is called the bin, and usually the rectangle is full of color. Okay, now in the lower part I have 3 different examples, or better, one example of the same data with different bin thickness. So the range that we are taking on the first case is very small, like, I don't know, like it's taking like a range, the thickness is like 2 or 3, and a lot of the time there is no occurrence of the data in those regions. So this probably is too small to have a good visualization of what we want. On the other hand, if we move over here, so the range now is in 50 minus 20, so that's 30. So that's very thick. So this is telling us like a summary of the information that basically is telling us that most of the occurrence is in between 10 and 50, or 50 and 80 than this region, but it's not really telling us any much detail. So we have to play with the thickness of the bin. So when we have like tens divided in tens, just divided by not 30s by tens, we can see a better distribution, and we can see some kind of tendency, and we can see that the most of the population is in the 60s, whatever is that we are looking, in this case, age of some population. Okay, so when you do histogram, it's important to play with the thickness of the bin until you get some information that is useful. Okay, let's have an example of a histogram. So we have the same data that we had before and that we did with the dot plot, but now we are going to group in a different way. We are going to use 6 bins. So the first thing that we want to look is the range. So what is the range of this data? So the range, so we look and we have to organize it to start with. So we know that is from 0 to 12. So the range is from 0 to 12. And we want to have 6 bins. So what we have to do is we take the largest value of the range minus the minimum value divided by 6, and that will give us 2, and so 2 is the range of the bin. So we have to organize our data in that range. So let me write the range here. So we have in between 0 and 2, well, it's going to be the first range, and is going to be, well, close at both sides. And then the next range is going to be in between 2 to 4, and is going to be open at 2 and close at 4, and we are going to continue 4 to 6, 6 to 8, 8 to 10, and 10 to 12. So we are going to look into how many elements are between 0 and 10. So in between 0 and 10, and sorry, in between 0 and 2. In between 0 and 2, we have those elements. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 elements. Now we're going to look into 2 and 4, excluding the 2. So that's going to be this region, including the 4. So that's 1, 2, 3, 4, 5, 6, 7. So we have 7. So that's that region. And next we are going to have in between 4 and 6, excluding the 4. So we have, well, basically the 5. So we have 1, 2, 3, 4, 5. So we have 5. And if we continue, so we are going to find that this is going to be 2, and this is going to be 10, and this is going to be 5. We keep counting, so you can do. So the way to plot, so we're going to select the bins. So the first one is in between 0 and 2, and we have 11. So we are going to have, and the next one is going to be in between 2 and 4, and we have 7. So that should be like that. In between 4 and 6 we have 5. 5 should be something over there. And in between 6 and 8 we have 2. In between 8 and 10 we have 10, and disappear. And in between 10 to 12 we have 5. Yeah, so that's our histogram for this example. Of course, later on we are going to learn how to do it in Python much more efficiently than doing this. Okay, let's continue. Look into different histograms, so we can see several tendencies. The first tendency that we are going to find is that the histogram could be symmetric. So that means that we have something like that, and most of the information is going to be distributed like we have a symmetry with respect to the mean, or in this case the mean and the median are going to be located very close. But sometimes the case is that it's skew to the right or skew to the left. And when I say skew to the right, skew to the left, the meaning is basically, if we say positively skewed to the right or right skewed, means that the tail is to the right. The tail is to the right. So in this case, it's going to be the tail to the right. And negatively skewed or left skewed, thus that the tail is to the left. So we are going to have something like that. And in those cases, the median value usually is in the peak. So the median value, so that's going to be the median, and the mean is going to be located in this case to the right and in this case to the left. So that's the mean, the average. Okay, let's keep going with this concept. So in this case, this is a skew to the left because the tail is over there. And what could be the case? So imagine that you have a basketball team and you're measuring the height. So that could be the case of the height of a basketball team. So in the case of the basketball team, most of them are going to be tall, and the few ones are going to be short, but they are probably very skillful. Okay. Another example of this case, it will be the grades in an easy exam. So it wasn't probability. Joking. So the grades in an easy exam. Yeah, you can see a lot of people have an A. A few people actually have lowest grades. This is a more standard situation, like for example the height of the people in a classroom. Of people in a classroom. And this is the other, so this is right skewed, so that could be a very hard exam. So most of the people fail, or could be the salaries in a country. I would say if you have the salaries in the States, probably is not that much. But if you go to countries like Latin America, in Colombia, Brazil, you will find few people very rich, and most of the population is very poor. And the rich could be very rich. Okay, let's keep going with modality. Sometimes we can see that the tendency is that we have just one peak. But sometimes we can observe that there are two peaks. So when we were looking, for example, to the waiting time for an appointment at the doctor, so the underlying information is telling us that there is something else that we probably should inquire. Probably we were like selecting all type of doctors, and it will be different for the type of doctor. Or could be, in some cases, more than one pick. So this is multimodal. So this is, the left hand side is unimodal, bimodal, multimodal, and this is more or less uniform. So this is something more or less uniform. So let me write it down. So we have one peak or unimodal, and this is bimodal. Should be bi, I'm not sure about the spelling, but should be bimodal. And the third case will be multimodal. And the last case is uniform. Okay. Finally, let's look into something that is called the boxplot. So boxplots are a very useful way of plotting information because it concentrates a lot of information. So first of all, we are going to organize our data set in this direction. So the axis is going to be in that direction. So at this point we are going to have the median. So if we have if we plot the frequency, so the frequency over there, so that will be the median, the point where most the middle point of the data of the frequency point. So that will be the median. And then we can organize the first quartile and the third quartile. Now, once we do that, when we find the first quartile and the third quartile, we are going to measure this distance. And that distance is going to be the interquartile range. Interquartile range. So interquartile range. So in short is the IQR. So the IQR is defined by the third quartile minus the first quartile. It's just that distance. So Q3 minus Q1. Now, based on that, we are going to define some limits. So we are going to define this line over here. So from the first quartile, we are going to move down 1.45 this distance, the IQR. From the third quartile, we are going to move up 1.5 of the IQR. So most of our data should be in that range. The ones that are outside are going to be called the outliers. So this is a nice way of seeing if we have outliers. So if we are at this distance, which is 1.5 from the first quartile down and 1.5 up of the third quartile, so if our data is outside of that, so those are outliers. And depending of the thickness of the IQR is telling us how sparse is our data set. The final way of relating data is the scatterplot. Scatterplots are useful when we have two variables. Like in this case, I have temperature and ice cream sales. So this is telling me how the ice cream cells are related with the temperature in Celsius. So we have different temperatures and different values for the temperature and how much was cell when that was the temperature. And it's not in order. But when we organize in the data set, it's going to be in order. Like we put first the 12s and 12 degrees, 14 degrees, 16 degrees, 18, and we put the cells. So what we need to see if there is a relationship in between temperature and cells. So scatter plots are useful to find relationship in between variables. Okay. In this case, we can see that as the temperature increases, so the cells increasing because people want to refresh. It's kind of obvious. Unless that you're in a place where there is no people, you're not going to have this tendency. Okay, but we have to do this with a lot of variables and a lot of experimentations. Part of the course will be based on trying to find out these relationships. So if we have our data plot, so we are plotting our information. So we have one variable x and y, and we are plotting, and we see that our information is like that. Well, in that case, we can say, well, there is no relationship. But if the information is organized in a different way, like if we can see a pattern, like let me do the pattern in a different color and in a different plot. So if, for example, we are seeing that the data is like that, so we can see that there is probably a pattern here. There is something like that. So there probably a function that is relating the variables x and y in this case. This is what we have for today. Thank you very much.